Okay, now a few words about how can we repair a neuron after it's been damaged. Now, sadly, remember few characteristics of these cells in the nervous tissue. One, neurons do not have centrioles. They cannot undergo mitosis after the fetal period of development. And neuroglia, they can divide. Okay, let's keep that in mind. So remember that one of the type of neuroglia, do you remember? In the peripheral nervous system are the Schwann cells. We have the satellite cells here protecting, hugging the body of the neuron, and then we have the Schwann cells forming, like rolling around the axon to form the myelin sheath. Remember that, right? Now, what happened? If the cell body of a neuron, either in the central or in the peripheral nervous system, is damaged or injured, sadly, that's the end of the story. That neuron dies. And we know that we cannot replace it, it cannot regenerate itself. The story is different if only the axon is damaged. And this applies only and sadly to the peripheral nervous system. So if in the peripheral nervous system only the axon is injured because an accident of any type of trauma that can section an axon, what is going to happen is that the area distal to the injury, this portion of the axon is going to be eliminated by macrophages. That's the function of macrophages, remember? So they come to the area and engulf and destroy all of these axon segments or fragments that are not viable. Now we're losing here, of course, the innervation to this muscle. Now this muscle is denervated. It's not being activated by this neuron. The proximal portion of the neuron is still alive. The axon yet is not connected to its effector. So depending of the um, damage, the number of axons or nerves that were damaged in here, and depending of the innervation of that muscle can be completely or partially paralyzed. Now, what happens is, or what can happen, this is not a rule, sadly, and there's just so little that we understand about these processes. But what happens if that the survivors' Schwann cells, they create like a cordon, and some stem cells might play a role in here. They create like a cordon or a guide, a path that guides the growth or the regrowth of the axon in here, of the neuron that was damaged. So the axon can slowly grow. It can take months up to years to grow until it reaches again the target organ, and hopefully the target organ can be innervated again. We can recover the innervation and we can partially or completely recover the function of that muscle. But again, this only happens in the PNS, in the peripheral nervous system. Why? Number one, well, we don't have Schwann cells on the central nervous system. And worse than that is that cells, neuroglial cells, especially astrocytes on the central nervous system, they produce a chemical that actually inhibits this process, inhibits the growth of the axon or the regrowth of the axon of a damaged neuron. So a lot of researchers, a lot of investment put now into trying to discover or uncover what's going on in different processes in the nervous system. And one of these researchers is aimed to find out a way to block with drugs, block these chemicals that are inhibiting the growth of this axon, or imagine that we can bring from the peripheral nervous system into the central nervous system, we can bring or transplant some of these Schwann cells or some of the mediators that the Schwann cells produce, that they stimulate the growth of the axon. So if we can bring some of these Schwann cells, some sections of nerves actually, or some of these substances that promote the growth of axons into the central nervous system, that will be so cool. That will be maybe problem solved with a lot of brain injuries and spinal cord injuries that so far have we have no cure for that. We have no way to recover the functions of those damaged cells. So there is hope. Let's see what happens a few years from now. See you in the next chapter. We're going to describe the central nervous system, so the brain and the spinal cord. See you.